Kia ora homa. In today's video, we're going to be answering the question to our Lego diver question that I posed a couple of days ago. And so if you're dying to know what the answer is, stick around and stay tuned to the video. So a couple of days ago we did an experiment called Lego Diver, and that's not the actual name of the experiment. I called it that to kind of keep it a secret and to stop you from finding the answer yourself and cheating, because I wanted you to hypothesize first. Now this experiment is actually known as Cartesian Diver, and it's named after the man that kind of came up with, they believe that came up with the principle, and I'm really sorry I can't remember his name off by heart. I think it's Cartes. And so this is the Cartesian Diver experiment. And they do this in a lot of different places around the world where they study hydrodynamics and physics and things like that, especially in naval academies around submarines. It's a really simple experiment to explain how a submarine works. When you set up the experiment and you've got your Lego man, who is what I would call neutrally buoyant, so he's kind of just floating just below the surface or just on the surface of the water. When we apply all that pressure to the bottle, what it's actually doing is making the water more dense. And so what actually happens to the diver inside there, that little air bubble that we've kind of trapped inside his head, and there's probably a tiny little bit of air trapped inside his body, is that water is pushing on that little bubble and making the bubble smaller. So when the bubble is nice and big, our Lego man is more buoyant than the water. But when we squeeze on the bottle, it makes the water more dense. Some of that water wants to push itself in and squeeze the bubble up, and then that makes the diver even more heavy, so he sinks down to the bottom. So does it make sense? So when we let go again, like I said, that bubble wants to expand again and makes the diver more buoyant. So it pushes that water away because now the water is less dense. Thank you to all of those people that had a hypothesis. Thanks to all the people that liked the experiment. There's lots of different things that you can use instead of a Lego diver. So if you don't have Lego at home, have a bit of a look at some of the other cool videos out there on YouTube. It's called Cartesian Diver, and I'll try and put the spelling to it just down here. But yeah, definitely Google, and there's some really, really cool experiments that you can do with a lot of other cool things at home that you'd easily be able to find in your kitchen and whatnot. And if you think about it a little bit outside the box, you could do it with some of the things of your own that you could think of that would make a good Cartesian diver. So I hope you like that experiment. Stay tuned to Mr. Ashley's Place, because there's going to be lots more experiments of this kind of ilk where you're going to get a chance to participate in the science along with me. So I hope you like that. And for now, ka kite anō, and I'll see you next time on Mr. Ashley's Place.